It's loading. We are live, yeah.
Hello, everybody. So,
hello.
I'll let John do some cheerleading. John, are you going to tell us to put our hands up?
Camera, action! Another episode of Tech Pride. I love that every time Jason starts a stream, he changes his accent and he goes, "Hello, everybody." I love it, Jason. It's like the tagline. It's like Aga Mataro. I don't know if anyone has watched his chess stream. He goes, "Hello, everyone. Welcome to another exciting game here between Magnus Carlsen and blah, blah, blah." It's like Jason's got his voice for the intro.
Classic. John, there's quite a strong reflection on your glasses. I think maybe you should.
Yeah, it's hectic, hey? I know. I actually asked my mates if they thought it would affect the stream, and they were a bit dishonest. But
nice.
I need to continue with my stream here. Almost a minute in here. Today is my stream. So today I'm going to be talking about...
Sorry, come again?
Yeah, so funny. So today we're going to be talking about GraphQL and the graph and why it's useful and how it's useful and why Wildcards is using it a lot and why we're probably going to be using it for a lot of our future projects. It'll be quite a high-level presentation, just the sort of high-level concepts. We won't go too deep. But essentially, the GraphQL is a schema that allows you to represent data in a structured way. And because it's structured, you can reason about what responses you'll get from the server. So you can actually use the structure, the schema, to organize your query. So you can choose exactly what data you want. And it's predictable what the server will give you because it follows the schema. So you can have like that connection between front end and back end really tight and well integrated because of the schema. So the schema is the glue holding the front end and the back end.
If I can add a quick comment on that, just to simplify, if someone's not familiar with the graph, just from a super kind of outer look, if you're familiar with REST, and like front ends communicating with back ends over this communication layer, GraphQL is an alternative, and there's a lot more to it, and it's much better in a lot of ways. But as from a stand-back perspective, you would say it's an alternative to REST type thing. So just for context.
Yeah. So with REST, I mean, REST has taken us really far. We've been using REST APIs for many years before the graph came out. But, there's a lot of challenges with REST. If you want very specific subset of data, the REST API needs to be handmade for each structure of data that you want. And you cannot change or adapt that on the fly. So the REST API is completely fixed. Whereas the Graph API, I will show you now, is very flexible, actually. So let's go to the current version. Yeah, we're busy upgrading the Wildcards graph. I'll tell you what this tool is in a bit, but for now, I'm just going to show you how you make a query. So let's go to Wildcards. We'll say
I need to add your screen to the stream. There we go.
Sorry. Cool. Let me zoom in a bit. I hope you can see it. Is that better? Yeah, cool. That should be fine. So we're going to say the first 5. So it'll just get the first 5 wildcards. And we want their ID. So you see what I mean? Like right now, I've got choices. I can choose how I want to get the data, what data I want to get, etc. If this was a REST API, there might be 3 different endpoints.
I got options to choose what to get.
John knows.
Have you heard that song before, Jason? Go give us a line. I got options.
I'll sing for you guys next stream. So over here is the sort of reference on the side. I can get the price. price, which is a big int, and time set. And we can get, I think, previous owners. And I think ID, time sold, time
so it's
acquired.
Quite flexible. You can essentially select the data points you want. It doesn't have to be a new REST endpoint for every single kind of query.
So yeah, I mean, if you look on this wildcard, look how much different data there is, and then it's like recursive. So like these objects link to each other, which is really cool. So I can, yeah, let's do this. Let's show the owner, and then I will show the address of that owner, and then I will show tokens, and then this is where it gets a little bit weird, but I can actually select all of this because each token is a wildcard, and I can put all of that inside. So I've just done a recursion. I'm going to turn this into a 1, otherwise it'll be overwhelming, but let's run this. There we go. So like I said, in owner, now I'm getting all the tokens that this owner has held. This is obviously a very active trader because he's held a lot of tokens. This actually must be Griff. I'd bet money that this is Griff Green.
Yeah.
But yeah, so you see what I mean? So this is the token, the top level wildcard, and then we've got tokens inside here, and we could grab like owner address. So now we can, yeah, you can see why it's recursive. We've got the owner here, and then we've got the owner for each of that owner's previous tokens, which is quite cool. There we go. And Griff owns most of his tokens, which makes sense. Yeah, here we go. This is a different owner. Cool. So now let's take a step back. This is cool, right? Like, we can get any data we want from the backend that's available, and we, as front-end developers or developers in general, get to choose the structure of that data. But how does this actually work? So there's various different backends, and because GraphQL is a schema-based approach, it's a specification. Anyone can write their own code, and as long as it fits the specification, the whole thing will work. So I think probably basically every major popular language, from Python to JavaScript to C++, will have its own way to define GraphQL backends. Some will be more user-friendly and polished. Some will be horrible, and you might not actually want to use that language if you want to use make a GraphQL backend. But basically, the implementation detail is up to you.
Jason, on that, from what I understood when I did some tutorials on GraphQL, the schema is really, it's designed such that the schema is the only document or the source of truth that both the people on the front end and the back end have to adhere to. Otherwise, you don't need to know how the back end actually resolves and handles those events to populate the schema. And it's the same. The front end doesn't care. They can just grab those values however they want. So it's quite a nice distinction.
Yeah, exactly. And you can go even one more step from there and say that the method of transporting the data doesn't matter. So typically you use HTTP just because that's what most of the internet's built on. But in theory, it's all schema-based, right? I could write this down on a letter, like I could copy this text, put it on a flash disk, attach it to my carrier pigeon, This is not the wildcards carrier pigeon. It'll have to be a real pigeon, and send this to you, John. And you could take that USB stick, put it in your computer, get the data, and then send this back to me. So it doesn't have to be over HTTP. It doesn't have to be over WebSockets. Okay, they used to show WebSockets here, but you can really choose whatever channel you want the data to work on. That's not part of the GraphQL specification.
And this kind of agnostic data transfer layer, REST, can you do this with REST, or is it not supported? Is REST strictly HTTP?
That's a good question. I actually don't know any REST APIs that aren't HTTP.
Yeah, me too. But
my guess is that maybe HTTP and REST really fit together. Yeah. So I mean, the sort of methods for HTTP are get, put, post, and delete, right? And those are very closely integrated with the REST API sort of best practices. So maybe it is connected.
Okay, we are 11 minutes 30 seconds in, so I wanted to ask you quickly before we dive further. So first of all, I just want to state that TheGraph is a specific kind of software that's developed by a company called TheGraph, and it's used for, why would you use TheGraph? In what context? It's specifically for Ethereum dApps, or is it agnostic of blockchain as well? And it's maybe a more efficient way to read data from a blockchain. And maybe you can expand on a little bit why, what TheGraph is, and kind of why it matters to use it. Why is it better than just reading from Infura and Smart? Yeah.
So before the graph existed, people would typically get data directly from the blockchain. And that's fine for very simple types of data, like who is the owner of this token? That's fine. You can ask Infura without any problems. So Infura is a hosted blockchain endpoint that you can access. And you don't have to use Infura. You can even host your own Ethereum node. But let's say your website required, well, let's go to wildcards. Wildcards, when it loads, it has to load data for, I think, 25 different animals. And it has to get all of the prices. It has to get all of the deposits. It has to get which animals are owned by which users. It has to get a lot of data, right? And if this was getting the data directly from the blockchain, it would probably have to make like 200 requests backwards and forwards of like, what animals does Griff own? How much is this animal? All of this data. It needs to fetch that. When was it acquired? How long has he been holding it? Whereas with the graph, you can, like I was showing you before, you can choose exactly what data you want. So on this screen, I need this data, right? So you can actually grab this data exactly with the graph, which is great. It means, firstly, it's easier for me to program the front end and to make this work. And secondly, it's much faster to load. I can refresh this page and it doesn't have to send like 200 requests to the blockchain.
Can I ask you maybe like a diehard decentralized question? With Infura, if you're not hosting your own node, is that not maybe kind of a centralized point where the data could be corrupted by Infura if they're passing you different data? And I'm assuming that would be different if you were self-hosting a node. And then my question is, can you self-host the graph such that you're not kind of required, that you're not relying on that data from the graph to be accurate, if that makes sense? Does the graph have access to change that data?
That's a great question. And a lot of people have heavily criticized Infura for being so sort of centralized, as it were. And it is true. If Infura has an outage, it'll send ripples through the whole Ethereum ecosystem, and that's not ideal when you're trying to build sort of an unstoppable global ledger like Ethereum is, right? So, in terms of trusting data from Infura, that's also a concern. Infura could try and manipulate some of the data, and that's also where, also a little bit off topic, things like light client research is super valuable. So with a light client, you can have like a small piece of data, which is the block header, like a little hash. And Infura can, in the future, when this is fully fleshed out as a spec, they can prove that the data they gave you is correct because it's inside that Merkle tree. And if the data is changed, it won't hash correctly to that block header hash. So there are things like this that can make the data more trusted. But, it's going to be very difficult to completely solve that problem when you rely 100% on something that's centralized. Even what I was saying, you still need to get the block headers from somewhere, right? So if you can't trust the source of your block headers, then you really are in the dark and you have no idea if the data is accurate. So the graph is currently centralized. So there's this company, where was it? Here they are. This is their website, thegraph.com. And they are busy hosting all of this, and it's a really great service. But they actually have had some minor outages in the last few weeks due to increased growth on their platform, etc. And that is concerning. But from day one, they've always said their plan is to decentralize their infrastructure. So the first thing is the Graph software is all open source. So you can go to Graph. Here it is, top result. You can go here and actually run their software, compile their software. They've also got a Docker file, which makes it very easy. So you're not reliant on them. And then in the future, they plan to allow anyone to basically host anyone else's graph data. To be honest, I don't know the details. It sounds like quite a complicated thing. But instead of running just an Ethereum node, they want people to run like graph indexing nodes. And if a lot of people are running them, that makes the whole network more resilient. So if the internet goes down in the whole of North America, the whole of Ethereum doesn't stop because, Ethereum exists in Asia and Africa and Europe. I hope that sort of makes sense. Maybe going one step back, there's various different ways to interact with the graph from the front end. I'm going to show you the three biggest ones, and there's plenty more that people have created. These are primarily the JavaScript libraries that I'm showing you. URQL, they claim to be the most lightweight solution. And there's a lot of customization you can do because it's so lightweight. I've looked at it, but I haven't done anything substantial in it. The next is, let's go to Apollo. Apollo is one of the older, more established libraries. I think very recently they released their version 3. It came out of beta, which is really exciting. So they're making progress. But Apollo is very, very sort of heavy duty, and people do criticize it for not being as flexible as some of the sort of competing frameworks. But, one of the things that's quite nice is the cache is very easy to configure. You can literally just install Apollo and not even know a thing or two about how caching works, or maybe if you don't know how the graph works or whatever, you can just throw in Apollo and it'll probably work pretty well just out of the box. So that's That's Apollo. Very easy to use. Go for it, Denim.
Quick query. This Apollo and URQL, I'm not sure you pronounce it. Are these kind of synonymous with something like Axios or Fetch from a REST kind of perspective? This is like the GraphQL equivalent. Or I know kind of, and maybe you can elaborate a bit more on why these are different kind of from the concept of GraphQL. Like what is different between URQL and GraphQL? Like what is the distinction between the two? The one I know is just kind of a protocol, and the one is more of like a software interface you can use to.
Maybe I can find it easily in the docs, but maybe I'll give up. Yeah, let's just search and see. I mean, I would say this is a higher level of abstraction than something like Fetch versus what was the other one you mentioned?
Axios.
Axios, or any of those libraries. Okay, no, I'm not getting it. But in Apollo, you can actually specify the sort of transmission channel. So you can create what are they called? Links. I think they call them links. So you can create a WebSocket link. You can create an HTTP link, and that will take in as an argument, if you don't want to use the default, a fetch implementation. And people can create their own types of links on, let's say they want to use UDP for GraphQL or whatever. You can create a link, and that's like a module that'll plug in to GraphQL, to Apollo. I think the main thing is around user friendliness. Basically, it's you can actually write. Well, let's give it a look. If I go to my inspector and look at the network, I'll show you what the raw. Here we go. I'm doing a stream, by the way, Dad. So I've just copied a link, and if I run this, like this is a curl command, right? You could literally build your whole website just using curl commands and not use these libraries at all. But then you have to do your own caching. Let's say you don't want to refetch the same data multiple times, or you have to do your own sort of loading management. So these libraries give you information about like the status of your request. Is it loading? Is it completed? And there's a lot of things that they build on top just to make it easy. So I hope that answers the question.
Great, that answered my question a lot. An example of the stack caching thing, I think we spoke about the other day, but essentially this caching does have kind of like a state management aspect to it. Essentially, you can use it to use global state across your application. Am I correct in saying that? So it's like a little bit of a Redux kind of functionality, which you would have to build over and above if you were to use your own kind of GraphQL solution.
Yeah, no, that's quite interesting. I wouldn't say that's very well established, and I wouldn't say that's very easy to do at the moment. But I know in version 3 of Apollo, they've added some more functionality to manipulate the cache directly. But for sure, it's not as straightforward as using Redux, for example. And maybe this brings us to Relay. So Relay is, I think, it's like this is the Ferrari of GraphQL at the moment. In terms of features and what you can do with it, it's definitely in a league of its own compared to these two. But that isn't always a good thing. Like I mentioned, I wouldn't recommend Relay to a beginner, and I'm actually not really experienced with Relay. But basically, Relay was created by Facebook as a way to solve a lot of their big challenges, and it works there's a few requirements. So not every GraphQL API is a relay compatible API. So one of the things is every node has to have a unique ID. So it's globally, so this is a node, right? Previous owners, price. Basically, all of these, patron is a node, like all of these top level things, global, token URI, all of these are nodes. So most GraphQL specifications don't require each of these to have a unique ID, but Relay does, and there's various cool things that Relay allow you to do with linking multiple items. So it makes querying better, and somehow because of each node having a unique ID, you can like fetch what they call fragments. So let's say you've already loaded the user's data. Okay, yeah, on the home page, we load all of the prices. So none of this stuff that I've written over here has been loaded. The only thing that we load is the ID of the wildcard and the price. But now the user navigates to another screen that should show the previous owners. When you're using Apollo and GraphQL, it would actually do a new request and it would fetch all of this as a brand new request. And sorry, let's close this. It would fetch it as a brand new request, and that's kind of a waste. Whereas Relay is able to basically look at your schema and say, hey, we already have the price. All I need to fetch is all of this other stuff. So it's like more intelligent in a way. And, you know, I haven't dug as deeply as I should in Relay to be a sort of authoritative like person on all of this. But yeah, at a high level, it's really powerful. Another thing that people talk a lot about is the new API for React. It's the Suspense Api. It allows you to like lazily fetch data while things are rendering, and a lot of cool stuff. Like on Facebook, I was reading if you hover over a photo, it like anticipates you clicking on that photo. So while you're hovering, it starts fetching data related to if you click on it. And all sorts of stuff like that are much easier with Relay. So it's really pretty cool, I would say. How much time do we have? Okay,
we
done
are
half an hour.
20, yeah.
I think, let me quickly show you some code. I won't go too into the details. But the question is, how does this get data from Ethereum? And it all starts essentially here in your schema, your config, your YAML config. Obviously, you need to have the address of your contract. You need to specify the ABI. Oh, here it is. So Stuart is the ABI. I can actually show you. Let's fold that up. Yeah. So this is the ABI, and this is something very common in Ethereum. It's basically the interface for the smart contract. And the ABI actually stands for Application Binary Interface. So reasonably similar to API, if you've heard that, but obviously smart contracts are binary. So that's how this is defined. And this configuration reads and scans through the schema, and it reads through which entities you care about and which events you care about. Oh, yeah, here's the ABI. Then it looks at this contract address on this network starting at this block number and just scans for any of these events. So if there's a log by event from the smart contract, it will run this code, handle log by. This isn't the most simple graph that I've written. It's got a lot of lines of code, unfortunately. But you can see here, handle log by, it runs this function and this new function, basically. So this code executes. And without going too much into the details, so this is buying a wildcard. It updates all these values for the patron and then saves it in the database. So once it's saved, anyone who queries the blockchain will get the latest, anyone who queries the graph will get the latest data that was set by this function. So you basically have all of this code running all the time, keeping the graph up to date. And this is, I think, one of the challenges with the graph. I could make a mistake. So the value on the blockchain is correct, but I could put wrong value here, right? And the graph will show that the last updated is wrong value, but that's not what the blockchain says. So this is, I guess, an important thing to understand and realize when you're working with the graph. The graph does get its data from the blockchain, but it's up to the developer to make sure that data is correct. Which is an important distinction. Let's undo this. And then the last thing that's very common to all GraphQL is the schema, right? So this has nothing to do with the graph. Specifically, all GraphQL, you have to define a schema, and you can see I've got this global entity. I've got these wildcards that have ID, token ID, price. This is its own entity. If I scroll down, here's the price. And all of this basically fits together and defines the interface that the front end will use. And maybe the last thing that I think is really cool with using a schema-based approach to defining your front end and your back end is, let's say I add a new, or I remove this field, right? So this field no longer exists. Because this is well defined, I can update the schema on my front end, and it'll immediately tell me there's an error. Actually, not all languages do this, but for example, we're using, what's it called? Reason, here it is. We're using this GraphQL PPX, which is part of Reason, and it generates all your types. Basically this paragraph. It generates all your types for you. So if you change anything, all you have to do is reload the schema, and it'll literally tell you exactly which line numbers you need to fix. Which really helps when you're trying to iterate fast and you've got a different team working on the front end to the back end, for example, or something like that. I would say let's open for some questions. Otherwise, I could go on for many hours rambling about GraphQL. So, anything?
If you were to, sorry, Jonathan, you know that awkward moment when you both pause waiting for someone else to ask a question.
Go, Denim, go over it.
If you were to say, let's say I want to get started straight away, what's the, maybe, do you have any resources that were kind of additionally helpful? Like, for example, maybe there's a GitHub of a basic, is there like a Create React app of GraphQL? I mean, the graph.
Sure. I definitely think it's getting easier. What's the backend that you're using? Like, there are some, I think it's called Figma, right? I've actually never used this personally. No, it's not Figma. Dana, what is the thing that you're using for that blog? It was like a GraphQL.
Oh, you mean
Prismic.
Gatsby?
Prismic, yeah.
Oh, Prismic, yeah.
So I think I've never used it, but I think Prismic out the box is the easiest backend to use. If you want to have more ability to customize things, there's Hasura, which is also very easy in my opinion. I think I've got it running.
Spice.
But
the next thing I'm going to ask you,
essentially,
Jason,
you can create your own data and structure it here. And I would say that using Hasura is nice because I don't think the barrier to entry is that high for very simple use cases. But if in the future you want to do very advanced use cases, Hasura definitely has you covered. It's a massively powerful tool in what it allows you to do. So, yeah, we could do a whole nother episode on Hasura. We're using it now for our backends. Go for it, John.
Hold on, there I go, Jason. So obviously we were talking a lot about REST APIs, and that's just like a vanilla endpoint where people can get stuff to, and GraphQL sort of being like a programmable API. It's a lot more flexible, and as you said, you've mentioned a lot of opportunities. But is there probably quite a bit of a cost-benefit analysis? I mean, GraphQL in the long run, I think, is easier for a lot of people, but there is a bit of a debt to get going and to understand it and use it, as opposed to, especially if you have a very simple application and you maybe don't need it. Do you think there's a trade-off where you would maybe say GraphQL is not for you, your application's super simple, you don't need it? Or, what do you think that trade-off looks like? And would you always recommend going the GraphQL route these days?
Yeah, so it depends on your previous experience. I think personally, I'm probably going to use GraphQL a lot, even for simple projects, because I now am familiar with Hasura, for example. And even if I only want to have one table and it's only got one field in it, I still feel pretty comfortable, like I can get started quickly. But it did take me a long time to get to this point. So yeah, if you already know how to use a REST API, I would say, yeah, just use it, build something. But you might find yourself limited at some point in the future. Also, I think, once you have the sort of basic principles of GraphQL and you understand how it works, it's not actually that crazy difficult, but there's that sort of hurdle to understand the concepts. Once you understand the concepts and you start, implementing things with it, it's less difficult. I guess that goes for most things. So yeah, I would say it's sort of personal taste. I would say using Hasura and GraphQL, for example, would make your code more maintainable, and it's more robust to changes and all of these good things. So there's no silver bullet, of course, as the saying goes. Each project will have its own requirements. I mean, and some projects really don't need fancy queries. It's like straightforward. Just use a normal endpoint.
Okay. No, I think it's obviously the architecture people are moving towards too, because it's a lot better. I was just wondering, maybe there's really simple cases and it isn't worth people's time. But I think you're right. It's a technology worth learning. So even if it's simple, it's probably the way to go.
I mean, like I showed you here with this curl command, you could set up Hasura, right, and basically turn it into it won't be REST. I mean, this is different to REST, but you can basically write a curl command for the backend. So if you don't want to make your front end complicated with, I don't know, Apollo or one of these libraries, you can query it directly. I guess something like Hasura is more, it's an easy way to set up a database and sort of persist your data. That's more maintainable than a lot of the alternatives. Here we go. They say try it in 30 seconds. I never really believe these claims that it takes 30 seconds, but they do try and make it easy for you.
29, 28, 27. Awesome.
Awesome. Thanks, Jason.
Yeah, it's a pleasure. Feel free to ask me questions in Telegram or wherever else you can find me on Twitter.
Cool. So if anyone wants to be as smart and knowledgeable as Jason, Marvin, do you have any questions, brother?
No, it was just a great introduction. I just need to agree that I think the problem with GraphQL is that you have to get the idea of GraphQL, and that's like the biggest hurdle. If you get past that, it's really nice to work with, and I think Jason did a really good job to kind of introduce us to that.
Cool. So if you want to level up yourself, then maybe get familiar and kind of climb that hurdle of getting familiar with GraphQL. So thank you, Jason. If anyone wants to be as knowledgeable as Zach here is, we will have another Share Friday next week at 12 p.m. I think that's in the day, Central European time. And then what are some of the other things we want to talk about? We want to maybe chat with Conlan from Async Art, although we'll have to change the time for that because I think it's like 3 a.m. for him right now. And we were talking about a Scale Arweave bridge. For those that are unfamiliar, it's Arweave, which is a file storage blockchain, and Scale is a layer 2 solution, and creating a bridge between the two. What are the other things off your head you can think about that we were discussing and talking about?
I think it would be exciting to talk about reality cards, which uses very similar contracts to wildcards, but it's a prediction market. So that would be Andy.
And that would be coming to a little bit of Harburg attacks, like we spoke with Simon. Cool.
And then, I'm sure we'll find lots of other interesting topics. So remember to hit that subscribe button so you'll get notifications every Friday.
Subscribe to your favorite YouTuber, Jason. All right. Thanks, everyone.
Peace out, legends. Till next Friday. Remember,
ciao.
Stay positive, test negative.
Oh, yeah.
And on that
like
note, goodbye.
Bye-bye.